Good morning, everyone. Welcome to the Utah Water Supply Briefing. I'm Trevor. I'll be presenting today, but I also wanted to acknowledge the forecasters who make all the forecasts throughout the state of Utah. It really is a team effort. Hang on. Okay. Today we're going to start off talking a little bit about our fall soil moisture conditions. Then we're going to go a little bit over the precipitation and snow conditions. We'll dive into our water supply forecasts, briefly talk about forecast error, and then we'll touch on upcoming weather and talk a little bit about our peak flow products that we have, and then we'll wrap it up with questions. As always, this webinar is being recorded and will be available on our webpage shortly after the presentation this morning. We will also have the slides available on our webpage as well. Heading into this winter season, our fall soil moisture conditions, we have a map displaying them as a percent of average on the left here. Throughout most of the state, we were near to above average, except for a few locations in central Utah. And the soil moisture conditions are important because they speak to the runoff efficiency. So typically when you have above normal soil moisture conditions, you would expect increased runoff efficiency. And conversely, if you have below normal soil moisture conditions, you would expect decreased runoff efficiency. As always, the actual spring runoff is really predicated on multiple factors, including the snowpack conditions, the spring weather, as well as the soil moisture conditions. Looking at precipitation for the past month, the figure on the left shows all of our basins and precipitation as a percent of average. And then the figure on the right, we show what we call major contributing areas. This can also be thought of as the high elevation areas. One thing in particular stands out in both of these figures is most everywhere we see a lot of reds and even purples, which indicate below average precipitation. And this was evident across most all of the state. For the month of April. The lowest basins would have been the Virgin and the Duchesne, and the basins that had the most precipitation would be the Weber and the Six Creeks basins. Looking at precipitation for the entire year, figure on the left is all of our watersheds, and then the figure on the right is the major contributing areas or the high elevation areas. Despite having a lower than average April precipitation, the water year precipitation, which is from October through April, remained near to above average for most areas, the exception being the southern tier of basins in the Sevier and the Virgin, where they were a little bit lower. Looking at our snowpack conditions, the figure on the left is our model SWE as of May 1st. Overlaid on top of that are the snow-till sites. On the table on the right, we have snowpack conditions summarized by basin. In general, SWE conditions declined in April, and this is a couple of factors that went into play here. The first being obviously the lower than normal precipitation, but many areas are also reached peak SWE during April, and melting processes have started to dominate by May 1st. Most areas, though, on May 1st were near normal, except for the southern tier of basins in the Sevier and the Virgin especially. Looking at our water supply forecasts, the figure on the left, we have a plot of our water supply points color-coded as a percent of average. And on the right, we have a table of select locations. Many areas, particularly in northern Utah, are near to above average, and areas in southern Utah and eastern Utah are a little bit lower. The select locations that we have in the table on the right, you can see a similar story. Many areas near to slightly above average, with the exception being Sevier and the Virgin, which are slightly below average. Diving into the basins, starting up north on the Bear River Basin, our forecast range from 90 to 150% of average. In the figure on the left, we have our May 1st model snow, color-coded as a percent of average. And you can also see our water supply points overlaid on top. The next series of slides will be arranged in a similar format, looking closer at the Bear River site at the Utah-Wyoming state line on the upper right. This is a plot of our ESP output. And just as a refresher, ESP is run on a daily basis, and it's a probabilistic forecast. And you can see that evident in the blue shading, which it represents the 90th to 10th percent exceedance. And then the blue line is the median of the run for that day. And then once a month, we produce official forecasts, which are evident in the pink bars, and those are also probabilistic. For the May 1st forecast, we have 111,000 acre feet, which is right about average for the Bear River at this location. One other thing that wanted to point out is the observed runoff, which is the brown line on kind of the lower right part of that plot. In this case, we have 15,000 acre feet that have run off since April 1st. And this is also updated daily, as you can see the runoff as it occurs. Looking at the lower right plot is a representation of the snowtail sites, or it's a plot of the snowtail sites, a number of snowtail sites in the headwaters of the Bear River. And you can see the evolution of the snowpack starting from January 1st. And by April 1st, we were sitting at 119% of normal. The peak SWE for this year reached 118% of the normal peak SWE. And then by May 1st, you can see melting processes have started. Moving to the Weber River Basin, we are forecasting anywhere from 105 to 130% of average. And looking at the Weber at Oakley, we have a forecast of 117,000 acre feet, which is about 105% of average. And thus far, we've had 21,000 acre feet of runoff since the beginning of April. Looking at snowtail sites in the lower right, in the Weber Basin headwaters, we had a peak SWE of 124% of normal. And typically, the peak SWE occurs by early to mid-April. Moving to the Provo River Basin, we have forecasts ranging from 105 to 130%. And looking at the Provo River at Woodland, our forecast here is 105,000 acre feet, which is about 110% of average. And here we've had 21,000 acre feet of runoff observed since the beginning of April. This particular site, the Trial Lake Snowtail site we have shown on the lower right, the peak SWE was 126% of average, 126% of the normal peak SWE. Moving to the Six Creeks Basin, the forecasted water supply runoff was between 115 to 150% of average. And looking at the Big Cottonwood Creek site in the upper right, our May 1st forecast is 39,000 acre feet, which is 114% of average. At this location, we've had 7,000 acre feet of runoff observed since the beginning of April. Looking at snowtail sites in the Cottonwood Canyons, the peak SWE was 131% of the normal peak SWE, and typically the SWE peaks at these sites in early to mid-April. Moving to the Duchesne River Basin, our forecasts range from 70 to 120% of normal. Looking at the Lake Fork water supply forecast point, we are predicting 55,000 acre feet of volume, which is about 86% of average. Thus far, we've had 7,000 acre feet since the beginning of April of runoff. And this site here, this is the Lake Fork Basin snowtail site on the lower right. Very interesting, by January 8th, early January, we're sitting at the lowest SWE on record at 57%. Very wet January, February, March ensued, and by April 1st, we were sitting at 112% of average. This particular snowtail site, this most recent storm that we had, pushed the SWE values to the peak SWE thus far at 101% of normal peak SWE. Typically, peak SWE at this particular snowtail site occurs in mid to late April. Moving south to the Virgin and Sevier River basins, our forecast range from 85 to 110% of normal. Looking at the Sevier River at Hatch in the upper right, our forecast is for 85% of average. And so far this month, we've had 12,000 acre feet of runoff since April 1st. I believe the 416,000 acre feet of volume is a typo, but it is 85% of average. Looking at the snowtail sites around the Sevier River Basin as a whole, our peak SWE was 116% of the normal peak SWE. And typically, peak SWE is during mid-March at these locations. Our model error, forecast error on May 1st is shown here on the figure on the left. And on the right, we have some select locations with the May 1st forecast error. In general, our error tends to decrease each month into the spring. And typically our forecasts perform better in headwaters and where we have a good handle of the diversions. And conversely, our forecasts are worse at lower elevations and where we don't know very much about the diversions and demands. Looking forward for the next 7 days, we just had a pretty strong spring storm system come through, which dropped copious amounts of moisture across northern Utah especially. That storm system will be moving out of the area. There will be some residual chances of precipitation through a good chunk of the week, but then we expect to see a slow warming trend with temperatures returning to near normal by this weekend. Over the next 7 days, the total precipitation is generally going to be below an inch. Looking further out in the 8 to 14 day outlook, these figures from yesterday, we're looking at near to slightly above normal precipitation being favored over most of the western United States. On the right, we can see that we're also expecting a greater chance for above normal temperatures, particularly over Utah from the May 14th to May 20th timeframe. So in summary, our fall soil moisture heading into this winter season was near to above normal for most of Utah, and that speaks to the runoff efficiency. Our model SWE on May 1st ranged from below normal to just above normal. The lowest was typically in southern Utah across the Virgin and Sevier River basins. Our water supply forecasts generally near normal to above normal across the state. Wanted to touch a little bit on our peak flow products that we have. We issue peak flow forecasts on our webpage, and it's a drop-down banner on the main webpage that you can select. You'll see a couple of ways we can represent our peak flow forecasts on the figure on the left. These are all of the locations that we issue peak flow forecasts for, color-coded as a percent of average peak. And really across the state of Utah, many sites are expecting below average peak flows, and then there's other sites, particularly along the Wasatch Front, we're expecting above average peak flows. Despite some of these areas having above average peak flows, in the figure on the right, we show the probability of these flows reaching National Weather Service defined flood thresholds. It's color coded in the green dots on the right figure. And at none of the locations are we expecting, or we're having a less than 10% chance of reaching these flood thresholds. Areas that are colored in gray, those are areas that do not have National Weather Service established flood thresholds at those sites. If we wanted to dive into a specific peak flow forecast point, this is the dashboard that would show. And there's really a lot of information here. The table on the upper left, this tells us a lot of information regarding when this is all based on our ESP runs. This is telling us when the model run date occurred, as well as our predicted forecast peak flow. In this case, this is the Weber near Oakley. On this date, this would have been yesterday, the 50% peak flow forecast would have been 1,633 CFS. And we can also see how this compares to normal, which would be 105% of average. We can also see when the normal time of peak occurs. In this case, it will be between May 20th and June 14th. And we can also see when last year's peak occurred and what that value was. The figure on the right contains a lot of the data that's on the table on the upper left, but in a graphical format. On the figure on the right, you can see the observed flows by that purple line on the bottom of the figure. That would be the observed flows to date. And you can also graphically see, when that peak flow occurred. In this case, it was 556 CFS thus far to date for this site at the Weber at Oakley. You can also see our ESP peak flow probabilities, which is shaded in the green, and that ranges from the 90th to the 10th percentile, and then the solid green line would be the 50th percent line. Other key points on this plot, you can see the shaded gray area. This would be the normal time to peak. And you can see a lot of the triangles that are in that gray shaded area. Those would be the peak flows that occurred historically. And you can see the 2023 is in black there. Looking at the tables on the bottom, these are the ESP output in tabular format. The table on the lower left would be our peak flow forecast in mean daily flow. The 50th percentile is 1,633 CFS. And then on the table on the lower right would be the timing. It is important to note that the magnitude and the timing are independent of each other. So we're not, in this case, we would not be saying 1,633 CFS would occur on June 2nd. We can't say that because they're independent. The timing really speaks more toward the normal time of peak. When the peak flow is closer to actually occurring, you can look at our 10-day forecast and see when we would be expecting a peak flow to occur in the next 10 days. And with that, this wraps up our water supply briefings. Today is the last one. So appreciate all of you tuned in today. And if you're interested in getting a hold of us, these are contact information for the various forecasters in the office and where they are responsible for forecasting. So with that, we'll take any questions. And I don't believe I'm seeing any at the moment. So if you guys do have any questions, if any of you do have questions, please reach out and contact any one of us. If you're not sure who to contact, you can always write to our operations inbox and we can forward that to the appropriate personnel. Or if you'd like, you can give us a call at that number. Thank you very much. Have a good afternoon.